Hello and welcome guys. In this video we're going to be looking at sequences and series, and in particular the three sequences will be arithmetic, quadratic and geometric. We sort of have like a table laid out, so I'm just going to go through this quickly and then we're going to do some practice questions that I've prepared from a certain past paper. Okay, so let's have a look at the first number pattern, which is an arithmetic series. An arithmetic series will have a constant first difference, which simply means that the difference between the first two terms should be equal to the difference between the next two terms. So term 2 minus term 1 should be equal to term 3 minus term 2. And so in general, we normally think of the first term as a variable. So let that variable be a, and let the constant difference be d. So if the first term is a, the second term would be a plus d, because you have to add a difference. And the third term would be a plus two differences, so 2d. And then so on and so forth. Eventually when you get to the 10th term, it will be a plus 9d. And so to be even more general with that, the general term would be a plus one less difference, so n minus 1d. Now there's also a sum formula. You can have a look at the formula that's shown below, the n over 2 bracket 2a, etc. And then there's also a real life example of where we might encounter these patterns in our daily life. For a quadratic sequence, notice we now have a constant second difference, and I'll do a worked example of this. So I'm not going to explain too much here, but you can have a look at the general formula there. That's important to note. Okay, so moving on to our last one, the geometric pattern. This one deals with a constant ratio, so when you multiply by some number each time. Now that multiple could either be a number greater than 1, which means that the terms will increase, or it could be a number less than 1, like a half for example, which means the terms will get smaller and smaller. This in general can also be written as a for the first term, AR for the second term, because it's a times 1 ratio, or for the third term, AR squared, that is a times 2 ratios. Okay, and so on and so forth. We notice that in general, this will be a times r to the power of n minus 1 ratios. Then this geometric pattern also has a sum formula that you need to take note of, and also a sum to infinity. Remember, the sum to infinity only exists if the ratio is less than 1. Okay, so I hope that was not too much theory, but let's dive into the questions and actually see how this is all done. So the question reads, the first term of an arithmetic sequence is -1 and the seventh term is 35. Determine the common difference of the sequence. Right, so in order to find the common difference, we'll start out with our general formulas. The first term is equal to a. The seventh term would be a plus 6 differences. Now the first term was given as -1, so I know a is -1, and the seventh term was given as 35. Now using a, you can calculate d. That gives us 36 equal to 6d, and therefore d is equal to 6. Now for question 2, determine the number of terms in the sequence if the last term of the sequence is 473. Right, if they give us the value of the last term of the sequence, you can use that to find the position of the last term of the sequence. If you have the position of the last term, you then know exactly how many terms there are in the sequence. So I'm first going to find the general formula for this pattern. Substituting into our general formula, a with -1 and d with 6, we can calculate by multiplying the 6 inside, then adding like terms. Okay, so the general formula is 6n minus 7. Now, substituting that tn with 473, I'm going to work out what n is equal to. Okay, take 7 across, so you have to add it with the 473, then you divide both sides by 6, and n is equal to 80. This means that there are therefore 80 terms in this sequence. Determine the sum of the first 40 terms in the sequence. So here we can just straight away make use of the sum formula. I'm going to go ahead and do direct substitution. So your number of terms is 40, that is the n. A's value is the first term, that's -1, and D's our difference. Right, punch this into your calculator. So our final answer is 4,640. Okay, just double check this with your calculators. Now this next pattern you see here is a quadratic. We have the terms 75, 53, 35, and 21. A quadratic pattern has a constant second difference. So to find out what it is, we first need to write out our first differences. The difference between 53 and 75 is -22. Remember, it's important to indicate a negative if the terms are decreasing. Then -18, and between 21 and 35, that's -14. Here we can see that our second differences is 4, +4, because our first differences are increasing. Now the first question says, write down the fifth term of this number pattern. To calculate that fifth term, I'll just continue with the pattern. That means our next first difference will be -10, and our next term would be 11. So term 5 is 11. The second question here is to determine the nth term for the number pattern. The nth term is the general formula. Now our general formula looks like this: an squared plus bn plus c. To find a, b, and c, we'll have to use the following formulas. 2a equal to the second difference. If 2a is equal to 4, then a is equal to 2. Next, we say 3a plus b equal to the first term of the first differences. That's -22. So substitute a with 2 and calculate b. Then to find c, a plus b plus c is equal to the first term of the sequence. Substitute a with 2 and b with -28, then calculate c. Here you can find that c is equal to 101. So a is 2, b is -28, and c is 101. Substitute this into your general formula: 2n squared minus 28n plus 101. And that's your general formula. Now this next question wants us to find the maximum value of a different sequence. However, this is also a quadratic sequence, and it does share some similar qualities to our previous one. The previous one was 75, 53, 35, and 21. The new one that is given is -15, -53 over 5, -7, and -21. This pattern is similar to our original pattern. The only difference is that each term is being divided by -5. Now, our original pattern wouldn't have a maximum term because it would have curved up all the way to infinity. However, this pattern, because it's a negative quadratic sequence, it would curve down to infinity. The term that had the minimum value of our original pattern would be the same term that have the maximum value in the new pattern. And if you think of a quadratic pattern as a parabola function, just know that the turning point of that parabola would be either the maximum or the minimum of that quadratic pattern. So I'm going to find the position of the term that has a minimum value of this original pattern. And we'll use this turning point formula, -b over 2a, where b is -28 and a is the 2. This answer is 7. So the position of our term with a minimum value is 7. Now I'm going to substitute 7 to calculate the value of our minimum term. So the answer for this is equal to 3. Now remember, the maximum value of this new pattern would simply be this number divided by -5, because that's what we saw with all the other terms. And therefore this maximum value is -3 over 5. That's your answer. Next up, we have a geometric sequence. Here the terms are 1024, 256, 64. And the first question is for us to calculate the value of the 10th term of this sequence. Here we can straight away use the general term formula for a geometric sequence. So let's write it down for this pattern. A is the 1024 and our ratio is a quarter because we multiply each term by a quarter to get to the next term. Now before I go ahead and plug in n with 10 to find the 10th term, I'm going to simplify this. 1024 is 2 to the power of 10 and a quarter is 2 to the power of negative 2. So if we multiply our exponents, we get 2 to the power of negative 2 plus 2, and then when we add our exponents, we get 2 to the power of negative 2 plus 12. Now, substituting n with 10 to find the 10th term would be 2 to the power of negative 2 times 10 plus 12. And so this gives us negative 20 plus 12, which is equal to negative 8. And the answer to this is 1 over 256. You could have just substituted n with 10 for that original formula you got. Then you'd get this answer right away. Now let's evaluate this next question. Here they want us to find the sum of the pattern 256 times 4 to the power of 1 minus p, starting from where p is 0 all the way to where p is equal to 8. Now, this pattern over here is literally the same pattern that they gave us in the beginning. If you don't believe me, substitute p with 0 into that formula and see if you don't get this first term. If you're still unsure, substitute where p is 1 to find this next term. And if you're still unsure, substitute p with 2 to find the third term. Okay, now that we agree that this is the same pattern, let's find the sum of these terms from where p is 0 to where p is equal to 8. Remember, if you're counting terms from where p is 0 to where p is 8, that's a total of 9 terms. If you think of p equal to 0 being the first term, that means p equal to 1 would be the second term and p equal to 2 would be the third term. So p equal to 8 would be the 9th term. Right, so we're basically finding the sum of 9 terms of this pattern. That means that n is equal to 9. So when we use the sum formula, so we substitute in, and the answer is equal to 87,381 divided by 64. This converted to a decimal is 1365.33 approximately. Now this is a very popular question. They give us the first two terms of a geometric sequence and they say determine the values of t for which this sequence will converge. A geometric pattern will only converge if the ratio is between -1 and 1. However, the ratio should never be 0. If we factorize this first term, you'll notice that it's equal to negative t plus 3 squared. And the second term can be factorized as t plus 3 cubed divided by 2. Now in the factorized form, it's a lot easier to work out what the ratio is. Let's think about this for a second. The first term is negative, but the second term is positive. That has to imply that the ratio itself is negative, because only a negative times a negative gives us a positive outcome. So we already know the ratio is negative. We also notice that our second term has an extra bracket of t plus 3. Right? So it has to mean that we are multiplying by t plus 3. But not only that, this division by 2 means that we also divide by 2 when we multiply with the ratio. Our ratio is exactly negative t plus 3 divided by 2. Now I'm going to substitute this into my formula over here. Now multiplying both sides by 2, that gives us negative bracket t plus 3. Then I'm going to divide by a negative, but this doesn't necessarily change anything in the inequality. Normally it would swap the signs, but since we have a 2 and a -2 on both sides, it really doesn't matter in this case. Lastly, I'll have to take the 3 over. That gives me -5 on the left hand side and -1 on the right hand side. And you should also remember the restriction, t cannot be equal to -3. Because remember, if t is -3, then the ratio will end up to be 0, and we can't have that. And that's how you answer these questions.